morning, everyone. BitConnect. Sorry, I couldn't resist for the last day. So welcome to this last day of our program, amazing program. And today we will finish the week with amazing speakers from different networks, blockchain networks. So I would like to see them fight, defend their network. Which one is the best? I would like to bring here the polygon, the polygon, the octagon, sorry. So we will start this morning session with a first presentation by ChainSafe. And we have here Philip Nendel, just there. So please, warm welcome to Philip. The stage is yours. Enjoy.
You took my joke with BitConnect, by the way. I wanted to do that, but all good. Welcome, everyone, and thank you for being here. My name is Philip, and I'm a BD lead at Sigma. First of all, thanks for being here. This has been the really nice couple of days here at ParisDOT.comm. So shout out to the organizers for hosting us here and doing this lovely event. Also, special shout out to people who jumped between ParisDOT.comm and DCC here close by. That's actually one of the main topics here today, is the interoperability between our two systems. More precisely, future-proofing interoperability on trust, security, and governance with Sigma. So let's dive into the presentation. So what is Sigma? Sigma is a modular security and transport layer that enables general message passing, interoperability, and seamless communication between EVM, substrate, but also beyond, in future. At Sigma, we have these 5 categories that are main components of our interoperability, and they drive our vision. One, beyond EVM. It connects natively EVM-based chains, substrate-based chains, and more in future. 2 is, of course, the public infrastructure, meaning building Sigma for common good, open source, and free. That's the intent, for this to be a public good. 3, cross-chain builder community, meaning we aim to create a thriving cross-chain builder community of contributors that help builders create and share modular components for effortless integration into DeFi, gaming, and other use cases. Of course, there is the real important part, number 4, tailored security, which means that developer will be able to choose between the 3 kind of options, a balance between security, cost, and convenience. And our adaptive security approach actually enables them to make optimal security choices based on their context and their use cases. And last but not the least, permissionless. We are committed to fostering a permissionless protocol to the greatest extent possible. This means that every project and cross-chain developer will be able to leverage Sigma with no need to ask permission or no need to wait for anyone to integrate their token or new tokens or new networks. We have everything that I just mentioned before. We have wrapped into this SDK, easy to use, and you can install and run it in less than 3 commands. Is it moving? Yeah, it's moving. The GIF worked, by the way. I would like to take you through a simple architecture, but I won't go into too much detail here, because I'll try and do the real demo after this slide, which will probably fail, but we'll see. So here we can see the Subbridge UI. It is a transfer UI, which is integrated into Sigma. In this case, it's Subbridge by Fala, powered by Sigma. So on the left there, you can see user connecting EVM wallet. Then they create a deposit. It's the orange, like number one. They create a deposit and they interact with the bridge contract. After that, it parses the deposit event is parsed. And on the right, you can see the set of relayers that between them determine a coordinator. Then they determine a signing process and execute the destination on execute the transaction on the destination chain. So let me show you a real example. Just to nope. Can I switch to? Okay. So here we can see the sub-bridge UI. We want to bridge from Ethereum to Fala. For example, 10 Fala tokens to this address. And here we can see the bridging fee, the destination chain fee, and estimated time. First, we have to approve the transaction. On the right-hand side, we can see the version 1 of the Sigma Protocol Explorer, and then we can, when the transaction is approved, we can then hit transfer and submit the transaction to the bridge. And now the transaction should be visible on the Explorer. Transaction confirmed, view on Explorer. And here we can see the pending transaction that I just did. So it kind of worked. Just a second. So, as I mentioned before, Sigma takes multi-layered approach to security rather than relying on a single mechanism. We also, of course, audited our smart contracts, and we have off-chain defense layer, meaning cutting-edge cryptography of multi-party commutation and threshold signature schemes, or TSS. Here is a Coinbase tweet from kinda like 2 years ago, but it's still very much relevant, saying secure MPC enables crypto assets to be stored, transferred, and deployed more securely, easily, and flexibly than ever before, which is true, still true. Sigma's development roadmap, or the future, or the road to trustlessness, At Sigma, we will now focus on two further phases to become fully decentralized and trustless. First, we will extend the relay network with trust-minimized nodes based on block header Oracle technology and secured with proofs of consensus, obviously optimistic, and validity, meaning ZK proofs. And phase two is end-to-end trust verification, or trustless, or to be more precise, trust minimized. Tailored security. Tailored security is kind of a big deal for us, meaning our vision for this protocol is that developers will be able to choose or users can pick, or in future, ideally it's even chosen for them, the level of security they want to, based on their context and use case and need, actually. So, for example, if you want to bridge tokenized loyalty points or whatever from your redeemable voucher, you can choose a quick, cheap, and fast bridging proof of authority technology. But on the other hand, if you have something really, really important and really, really valuable for you to bridge, like a JPEG of a rock or something like that, then you can actually choose something more suited and tailored, more secure solution, utilizing trusted relayers and zero-knowledge proofs. And finally, for decentralized governance or multi-sigs to meritocracy, Sigma is and will be contributor-owned interoperability layer, and so it will be its governance. Phase one, which is, we have divided this in two phases. Phase one is the phase that we are currently in, meaning where we use multi-sigs. Gnosis is on Ethereum side, obviously, and also a big shout out to the team at ChainSafe and Thibaut for developing this great tool, Multics. And phase two is obviously where we will extend governance not only to the multisigs, but to all contributors. With this, I would like to finish my talk, and thank you all for coming here in such a nice number after the parties yesterday, I assume. But also, one more thing. As you can see, Sigma is making great progress in interoperability, but we still have some way to go. This is why I would really like to invite all of you, the community, to come and build with us. You can either scan this QR code, we have a booth there, you can reach out to me directly or in any way, but please reach out and let's continue shaping the future of interoperability together. Thank you.
Amazing. Congratulations, Philippe, for showcasing a demo during an event. It's sometimes touchy, but it worked well. Perfect. We can applaud him.
Yeah.
Thank you.
Thank you.
Perfect. Okay, so I don't know if you take back the computer or I let you manage. Okay, so now we can welcome the next presentation with Horizon. So we have Manon Boudou and Giacomo Guccioni. Sorry. Okay, so you can come in. We can applaud them. Warm welcome to them. And so you can have a seat. And the stage is yours. Yeah, the pointer. Here you go.
Hi everyone. Maybe the first slide could be great. I don't know how to put the first slide. But first of all, thank you. We are very happy to be here today on the stage to present Horizon. So thank you, the Polkadot community, for inviting us and giving us the opportunity to present the Horizon project. I'm here today with my friend and colleague from Horizon Labs, Giacomo Guccioni, and I'm from the Horizon teams. So today, okay, maybe I've
have to point it.
Est-ce que je pointais quelque part ou... Merci. Ok. Ah, ok. Merci. So during this presentation, we will present the Horizon, so from its origins as Zencash and how it became an interoperable network. Also with the new Horizon Eon sidechain that is EVM compatible. So we will see what was Zencash first. We will do a short dive into the CCTP protocol, so between the main chain and our sidechains. Then we will go through Eon, the Gobi permanent testnet, or bug bounties, and what the community can do to help us. Horizon started in 2017 as Zencash, so that's a fork from Zcash that is itself a fork from Bitcoin. So we had and we have today the private transactions, so the user has a choice to do a private transaction or not, and also private messaging, so thanks to our different tools. With the years, we became the pro in the ZK snarks industry, and that's how we became today the zero-knowledge network of blockchains. That Giacomo will tell you more about that.
Thank you. And yes, definitely. No, it was a big journey. You can see here in this slide, fast forward of 6 years from being just a cryptocurrency, let's say, to being an entire ecosystem. And everything starts with Zendu, our cross-chain transfer protocol. We'll name it CCTP from now on. And everything starts there. This is what opens the possibility to the rest of the ecosystem, and we will talk more about that in a second. But just worth mentioning, and we will cover that more as well, some keywords, not only keywords, but steps we have taken, components of our ecosystem that are a key parts of our technology stack. So starting from Zendu, then we have the nodes, of course, of our network that we call the Zen nodes. We started developing our wallets. You can see here mentioned the Sphere, which is our flagship wallet, useful for the main chain, and Cobalt wallet, which is our super easy to use, browser integrated wallet used from our sidechains, and of course the sidechains themselves. Here mentioned Token Mint and Eon. We'll talk more about that in a second. Let's start from the very beginning. So it is worth to spend a couple of minutes just having a look at the very core of our model, which is, as I was saying, this CCTP. So basically, here we are talking about a software component that is integrated within the Horizon main chain as well as within the sidechains, and that enables interoperability and communication between these two systems. It is done via enabling communication of messages, let's say in general, but more specifically, we can talk about moving assets. In the case of our Horizon main chain, we're talking about Zen, our currency, and we can do it with two operations, which we call forward transfer and backward transfer. And as the name suggests, forward from the main chain to the sidechain, and then vice versa, from the sidechain back to the main chain with the backward transfer. More on the backward transfer is more complicated than that, because backward transfer requests are encapsulated within certificates that do not contain only the backward transfer request, but contains also what you can imagine as likely snapshots of the current status of the sidechains, of the sidechain that is submitting the certificate. So basically, you can think as a commitment of the sidechain to a determinate state in time on the public decentralized proof of work Horizon main chain. All of that, of course, is covered in our white paper. It was wrote and published 3 years ago. Then the development started. 2 years ago live in mainnet, and this is where the possibility starts now, because after that, sidechains can be a thing in mainnet, and everything starts from there. One last thing on that slide is this is the first interoperability protocol in the Horizon ecosystem, not the last. Here we have interoperability between main chain and sidechain. What we are currently working on is interoperability between different sidechains. So let me say on the childs, no? And something we'll hear more and we'll also mention during the presentation. But now that we have the basics, let's see how the journey has been.
Thank you, Giacomo. So yeah, we started in 2017 as Zencash, and right after we were born, we started with the secure nodes. To be clear, Horizon is a proof of work blockchain. So the coins that are the blocks that are added to the chain are mined by the miners. But we created the node layer to have more security on the network. So to have nodes to verify the transactions the miner added on the blockchain. So to reward the secure nodes, we give them a part of the coin-based transaction that is won by the miner. So we started with these secure nodes. So with 32 Zen to stake in order to run to all the secure nodes, and that was a huge success. Then a bit later in our journey in 2018, we were victim of a 51% attack. So to mitigate the risk, we wrote a white paper and implemented a solution to mitigate this risk. So we penalize the delayed blocks that are broadcasted delayed on the network. So this solution is available for any proof of work system in the industry. Later in 2018, we became Horizon. And we also published the first white paper about sidechains. So the technology changed meanwhile, but interoperability was at the core of the project as its beginnings. In 2019 again, we created the Sphere wallet, so that's the main chain wallet that is useful to all the nodes, but also to do private transactions and also private messaging. That's the flagship wallet. You can also have news about Horizon within the wallet. In 2019, we created the Horizon Academy. So at first, that was very focused on blockchain, cryptocurrencies, and a Horizon project. But today, you can also find a lot of information about the DeFi ecosystem, about smart contracts, and the apps. So everything related to interoperability, EVMs, and all the new features that we have in the blockchain industry today. In this year, we will also see the birth of Horizon Labs. So that's the company that builds projects and services on the Horizon blockchain. So, for example, I am from Horizon, and Giacomo is from Horizon Labs. This same year, we also created the super node. So instead of staking 32 Zen in order to hold the node, that was required to stake 500 Zen to host a node. So then in 2020, we released the Zendu white paper, and just after, the Zendu network was open, so that permitted to Horizon to become a layer 0. So in 2021, we created the HDE. So that was a place to permit to any committee member and ambassador to go on Horizon to perform some task and be rewarded for that. We had the first ecosystem halving in 2021. So now the miner gets 6.25 Zen every time they mine a block. We had the Blaze SDK released on the same year. So the Blaze SDK permit enables any developer to build a sidechain on the Zendu ecosystem. And we released our first sidechain that is more a proof of concept sidechain that was released in 2022, the token mint sidechain. So to permit to anyone in the Horizon ecosystem to mint tokens and mint NFTs that will live inside the Horizon ecosystem. In 2022 as well, we released the Cobalt wallet. So that is was useful at first for the token mint holders, the one who built on a token mint, so to exchange token, to create them, and to view NFTs, and is now useful to mint and to live with the Horizon Eon sidechain and the Gobi testnet. And so yeah, the Horizon Eon sidechain, the EVM compatible sidechain was released this year on testnet and is soon available on mainnet. But I let Giacomo tell you more about this Horizon Eon sidechain.
Yes, sure. So finally, Eon. Eon, what is Eon? Eon is a sidechain, basically, but the important thing is our latest sidechain, and is the first sidechain ever in the Horizon ecosystem, being fully Ethereum virtual machine compatible, while implementing our CCTP protocol, so being part of the Horizon ecosystem. So this is basically our step forward into smart contract capabilities world. And looking at this representation here, you might think it's somehow representative now of what we were seeing before on the explaining on the CCTP, and indeed it is. The difference is that what we are looking here right now is not prototypes, is not proof of concept. We are looking at two existing chains, blockchains that are side chains within the Horizon ecosystem that live in parallel and do their own business, let me say, in parallel with the main chain. And the key takeaway also is that there are differences between those two sidechains. What remains the same is implementing the CCTP protocol, but they have different models, like token mint, for example, is UTXO based. Eon is account based, of course, different consensus parameters. So what remains the same is the protocol implementation, then up to the sidechain to implement and make changes and tuning based on the use case you want to serve, or in other words, the problem you want to solve, maybe. And back to Eon, it was, as I said before, is our latest sidechain, and our biggest effort is in the Horizon space. Why do I say Horizon space? Because it was not only the effort from the company Horizon Labs I work for, but also a joint effort with the community. Because, as Manon will walk us through, we have gone through different stages in testnet, always looping feedbacks with the community, leveraging the communities as testers also, providing feedback on our functionalities, and that's how we kept the quality bar high, and that's how we are approaching mainnet, delivering constantly software in incremental value in an agile way. But yes, let's see what the stages have been from till now and what's next very soon.
So the Horizon Eon journey started approximately 1 year ago. And in December, we had already our first private testnet, so aimed to the team and the key ambassadors, developer ambassadors. In January, we launched the June testnet. So to be invited to the June testnet, you had to be on the developer newsletter, and you received an application form to deploy on this June testnet. Then in February, we launched the first public testnet, Yuma, that lasted approximately 2 months. And then we saw the Gobi permanent testnet in April. So that will remain the Horizon Eon testnet for anyone to test their dApp and smart contracts before deploying on mainnet. The mainnet is being released soon, very soon. So if you want to be the first to know, feel free to follow us on our social media, on Discord, on Twitter, and Telegram, and also on our developer newsletter to not miss this opportunity. But going back to Gobi, we have now 15 partner integrations and even more because there is a lot of integration coming again today and even this week. So we invite you all to test our Gobi testnet. You will have the link at the end of the presentation. And because the idea, we want to build something that is made for the developers and by the developers. So feedback is really important for us. So feel free to test on Gobi, give your feedback, tell us what tools you would like to see on the testnet, and we will be happy to answer your needs. We also have some bug bounties program. So we have one right now with Humanify. So if you are already a great developer or a developer willing to test and to see what is wrong with our sidechain, feel free to do so. We have the bug bounties for that. And we also have some hackathons. We have one that just ended one week ago, and we will have more in the future. So for that, stay updated to the news, so Twitter, Discord, and even the developer newsletter. So that was for Horizon Neon and the Gobi testnet, but we also had a very important news this year that was taken with the community about the deprecation of mainnet shielded pools, and I will let Giacomo tell you more about this news.
Yes, thanks. So as you said, changing subject, so moving away from Neon and all of that, you do remember our foundation is still the main chain. It's still our Horizon main chain, fully decentralized and proof of work. So basically, we have a various engineering team working on our software stack, and the main chain still is always improvement on the main chain will be part of our effort. So with this Zen improvement proposal, what we are proposing. If you do remember when we said that Horizon start being basically essentially a privacy coin, this is the first step moving away from that. First of all, because it is a limitation somehow, we don't want to be just that. Then, of course, worth mentioning, we want to meet regulators' demand. And we think that preserving privacy on the main chain level is not the only way we can offer privacy capabilities. We have the sidechains, we can talk about selective confidentiality. There are other ways, better ways. So basically, this Zen improvement proposal for 2204, it will be the first step in that direction, basically removing the possibility for user to add more Coinbase to what we call the shielded pools. So shielded transaction, basically the possibility for users on the main chain to move assets from to a sender to a receiver without disclosing the sender, the receiver, and the amount. The first step will be to disable the possibility on a consensus level to shield new Coinbase that actually is in the transparent address. So reducing the impact and the amount of the shielded pool on our all Coinbase. And yeah, and moving on from starting from that, no. If you are interested and want to join the conversation, because of course there are conversation ongoing, I strongly suggest to join on Discord, because on our in that space on various channels there are very interesting conversation with long-term community members and of course team members of Horizon Labs. So please, if you are interested, check this out.
Yes, exactly, because like for the Zen IP, as we mentioned, the decision was made with the community. We drafted the Zen IP in January. We had a lot of talks with the community about the Zen IP. Should we remove the shielded pool transaction? Shouldn't we? And the community agreed by 80%. So that was a huge yes from the community, and that's why we're moving on that. And so we have the testnet and mainnet incoming. We have this very global community. So here you see the pictures from a lot of meetups that we did all around the world. So that's a pretty global community, and that's also the strength of Horizon, but also of many cryptocurrencies and blockchain, because we can share the knowledge and the strength between each other. If you want to join the community, you can as a developer, you can as an ambassador, you can also just as a believer. You can also join the team. You can also deploy anything you want on Horizon Learn and Zendu. So feel free to join us. We will be happy to have you. This is the end of the presentation. So here you have 2 QR codes. One to have the website on Horizon Learn, so to deploy on our new EVM sidechain, Noan testnet, and also to join the newsletter to be the first to know when the mainnet is released. Thank you, everyone.
What a journey, Horizon. Nice. Thank you, Manon. I need a revenge. And Giacomo Gussoni. Thank you very much. So we will continue with our next speakers from Near Protocol Pagoda. It's David Millard-Durant. Are you there? I see you. Perfect, you are just on time. You have your microphone? Okay, you have got one here. It's okay here. And this is the pointer. Yeah, just next. The stage is yours.
Hi there, everyone. I'm David Millard-Durant. I lead the Emerging Technologies Division at NEAR. And it does work, fabulous. And yeah, it's great to be here. So today I'm going to be talking to you about the BOS, B-O-S. So it's really, really good to be at a ParisDOT conference, because for a long time we felt that sort of as a relatively small ecosystem, fragmentation is going to absolutely kill us. You know, sort of it's, for a long time we've been competing with each other and trying to build separate things and having separate ecosystems. And I'm really, really excited to sort of new multi-chain approach that we're trying out. So first of all, caveat emptor, haven't quite had time to run this speech by anyone in my company. So all opinions are my own. But yeah, so for those of you who live and breathe ParisDOT and have never heard of NEAR before, we are a chain that was launched in 2020. We're sort of your classic workhorse L1. We do very fast finality, so we finish in about 1 second. We run on WebAssembly. We're cheap, about as cheap as these kind of protocols can go. And we scale, which is, those are all sort of pretty nice properties. But also from another perspective, they're much more reasons not to be turned away from the protocol. You know, sort of it's not so slow that you can't use it. The latency isn't so high that your applications will grind to a halt. If you have a large application that does a lot of transactions, you're not going to bring the network to a halt, or the gas fees aren't going to go through the roof. And one of the problems we have as an ecosystem is that there's kind of a lot of networks that fit that bill pretty well. You know, sort of there's that are fast enough, cheap enough, scale well enough. So we sort of ended up in a situation where developers would look at these sort of groups of because I mean this could well describe ParisDOT in a lot, ParisDOT in a lot of ways. So we end up in a bit of an awkward situation there, which is that developers would effectively roll the dice to pick a blockchain. They would sort of go to some random hackathon, have a name, like have a friend who recommended something, or just sort of really like the logo of their chain of choice, which basically just led to an inability to build sort of really good ecosystems. You know, sort of a DEX is nothing without tokens. A marketplace for NFTs is nothing without NFTs. And when you have those things living in sort of 30 different places, you lose the ability to sort of reach that tipping point of having a big enough community to start attracting more people than you lose. So, you know, we sort of built this chain in 2020. We really liked it. We thought it was great. And then we did the same thing everyone else did. We saw this happening, and we went out and we did evangelism. We have a fabulous DevRel team who put a crazy amount of work into getting as many people understanding and using this protocol as possible. But so did everyone else. So we still end up with this sort of really, really nice fragmented ecosystem where, you know, sort of no one dominates. When you look at a chain, you don't say, generally, that chain does this thing so much better than anyone else. So I have to use that chain. That's the obvious place for all of my applications to live, except maybe Ethereum with sort of the concentration of capital. So yeah, that's sort of the history. So we're still growing. You know, we've got a pretty good growth rate. Last year, things are going relatively well. We've got a pretty high number of sort of total accounts and a pretty high number of active accounts. But, you know, sort of collectively, us and every single chain like it are about the same size as one large American tech company. So how do we fix this? About 9 months ago, we sat down and we said, this is not the hockey stick of growth we were hoping for it to be. And we said, let's focus on the things that we're better than anyone else at. And sort of laser focus, because what we built was an everything blockchain, a chain you could use for every single application sort of equally relatively well. And instead, what we're going to try and do, using this thing we call the boss, is focus on the strengths of our chain and focus on making sure we can use the strong parts of our chain on everyone else's chain. So, you know, sort of deal with one small part of the application. So this is the boss stack, sort of distilled down. First, let's talk about onboarding. For anyone who's worked in the space for any period of time, you know full well for onboarding users, wallets absolutely suck. Someone comes along and they want to use your CryptoKitties application, and you've got to explain a 22-step process involving 2 rounds of KYC, some sort of magical set of 36 words that they've got to remember, but don't, you know, write it down anywhere or else it'll get stolen. Scary messages telling you, you know, here's some technology you really don't understand and you're going to have to use it. You've got to go to an exchange, you've got to talk to people. It's entirely inaccessible to lots of the world, and it's a real pain in the ass for even those of us who are most connected. And it can take, you know, half an hour. And we are seeing with wallets, when people had to fund their accounts, attrition rates in sort of the very high 90s, so sort of 95 to 98% of your users disappearing. And that's terrible, because it's not just the users you lose that day. You know, sort of an ecosystem for a product or sort of the users of a product attract other users. And at some point, you reach sort of a tipping point of having enough users, and your users start coming more easily. With a 98% attrition rate on people actually onboarding to wallets, you're going to find that it's very difficult to start that sort of metaphorical fire of a community. So the first, we also have some other things to talk about later. So the first thing we did was we effectively reversed our gas model. So we realized that making users pay up front to use their gas was making people save tens of dollars in gas, and we're losing thousands of dollars worth of users, which is kind of insane and not anything people would want to do. So we reversed our gas model. We gave people the options to, when you build a smart contract, to pay for users to use your smart contract, much like you would in AWS. So you basically just put credit on it, and people can use that as much as they like in situations decided by the smart contract using a technology called relayers. The next thing we did was we made our wallets much easier to sign up to. We made this thing called FastAuth. Interesting, that was animated on my slides, but apparently not anymore. Anyway, FastAuth is very, very simple. What it does is you sign up with an email address, you sign in with sort of any compatible OAuth account, and our smart contracts take a proof of the ownership of that OAuth account and can use it as a key. And this is really sort of connected to the thing that Near does best, which is accounts. We talk about the other things far too much, but the one thing Near does really well is accounts. We have the ability to have effectively Turing-complete code run on each account, which allows you to use absolutely anything that you can prove as a key. Hold keys that have scoped access. So, for example, you can have a key which can only call a single application, or can only call a single application on a Tuesday, or can only withdraw up to one Near at a time, or one Near in a week, or whatever you want to do. And that allows you to write logic where you can say, hey, you can sign in with an email, you can sign in with your Google account, but if you want to withdraw 10,000 Near, you need to attach your ledger key. So that's kind of cool. So yeah, we have using passkeys and using emails, we have a standard Web 2 onboarding experience. And we saw our sort of conversion rates go from, our loss of conversion rates go from sort of the high 90s to about 75%, which 75% doesn't sound great, but if you think of the change between sort of 2 or 3% of your users sticking around and sort of 20 to 25% of your users sticking around, it's quite a big difference. You notice it when you start building products, and you notice the sort of rate of onboarding really picking up. And we've had real success with partners kind of jumping on this, because sort of, would this slide have been animated, you'd see it takes about 3 to 5 seconds to sign up and make an account, which is very good. So yeah, we think we've got onboarding down. The next thing we want to do is attach this, so you sort of have your key management there to some extent. We want to make it really, really easy to deploy a front end which is sort of hosted in a decentralized manner. Right now, hosting front ends is, you either do it on Vercel and you hope for the best, or you just have to go through some sort of crazy hoops about finding somewhere to put it, having some sort of account on it, all this kind of stuff. What we built is a series of sort of composable React components, which can be hosted in a decentralized context. So every single small bit of React that is connected to a smart contract can be picked up, edited, and dropped into your application with no reliance on the individual who made it. So first of all, the component can't escape from its sort of little area. It can't draw over other components. It can't take keys. It can't do anything like that. It's very much sandboxed in sort of a virtual environment. And secondly, it gives you the ability to remix very easily everyone else's code that you see. And it's all included. So there's zero hosting setup. You literally just edit your code, you push a transaction to the chain, and suddenly you have a website up and running, which sort of makes things much easier. One of the things that we had to do when we were doing this was somewhat loosen the definition of decentralization, which it was a bit of a shame. But as anyone who's tried to make websites on chain here will know, practically, it's very, very difficult to host a website in an entirely decentralized way. Fundamentally, someone has to own the domain name. Someone has to, maybe not entirely, but someone generally has to own the SSL certificate. There's all these kind of things. And also fundamentally, all these sort of very secure chains, you have to host a very small piece of JavaScript which bootstraps whatever kind of verification you're going to be doing. So we said, how can we keep the spirit of decentralization alive with these constraints that exist? So what we say with our front ends is decentralization is the ability to switch provider at the press of a button without losing anything. So anyone can host a sort of near.org style website. You can just deploy it to Vercel. It'll start working automatically. You can buy your own domain. You can use it. You can customize it. But we're just one of the first places people drop into. So this is one of the places where you can get the things you need. And so yeah, this is live right now. And the final part of it, which is most interesting for this conference, is the multi-chain side of things. Now, the multi-chain side of things isn't quite finished yet. We've still got a lot of work left to do on that. But effectively, what we're going to have when it is done is the ability to hold private keys inside of a smart contract. Now, obviously, holding private keys in a smart contract is very easy, provided you don't mind if someone can steal them. But what we want to be able to do is have the ability for smart contract logic to sign arbitrary messages when it's sort of programmatically made to do so. So, for example, if you have a Solana app, what you will do is sort of request permissions to sign Solana transactions with this key to the user, and and you can put arbitrary restrictions on there once again. So you can say if this person spends more than 1 sol in a day, they need to go through some other form of verification. You can do the nice onboarding stuff we can do, which is to pay for certain applications to be used for free. So you basically load up some funds onto a key and say you can only use this key if you are using my application and sort of under these circumstances, which I think is really, really cool once it's out. But my team is going to have a lot of sleepless nights between now and then, making sure it's all secure and well done. So yeah, the use case for the boss is your application already lives where your application lives, and it lives there for good reasons. What we want to do is you keep your backend where your backend is, and we want to make things better on the front end using the NEAR protocol in as many ways as we possibly can. So I've talked about the big things: onboarding, keys, security, authentication in depth, like what you have in Google, where if you check your emails, you don't need to type your password in, but if you try and change your password, you do need to type your password in. And then we're trying to add 1,000 little things to make all of our developers' lives a bit better. So everything we built is optimized for sort of speed of learning, which is how quickly can you go from nothing to an application? How quickly can you iterate on your application and get it out to your users? And how quickly can you look at someone else's app and change something you don't like about it, which I think is the coolest kind of thing, so the remixing aspect of things. So we have an example flow here. Here's this chap who looks suspiciously like Lionel Messi, and he would really like to make a workout app. We have a big library of components right now, over 1,000 in the NEAR store, and what he can do effectively is he can look at existing components, pick them up, and throw them down into his app. So that's kind of his idea. So as soon as he signs in for the first time, he automatically has a developer page. The reason for that is we want to get people to spin out their own applications as quickly as they can and have zero friction in between sort of using something and editing it. Sort of very much in the spirit of the blockchain way of doing things. So obviously, Idris lands. He doesn't have any components, but he can go over to Mintbase, who does have a bunch of components, and he can just go in and immediately take a look at it. It's got, you can look at it working, you can view the source, you can share it, but most importantly, you can fork it. And when you fork it, you get sort of access to sort of very, very simple, all it is a React component, which you can edit in the browser. Obviously, you can also fork it on GitHub, which is not a big problem for those of you who like using real developer tools. And you can edit it, change it. We have a very, very simple sort of no SQL, store your data. Don't worry too much about how it works. Technically, you're writing a smart contract, but you'd never know. You write how it looks. You pick up the components you like. You put them down, and suddenly you have an application. So you'd kind of think that's where what we're doing to help you would end. You have your onboarding, you have your multi-chain stuff, you have your front end, you have your hosting, but we try and keep going from there. So yeah, there's a lot of benefits to it. But we want to help you do acquisition as well, because getting your first 100 users is really, really difficult in the Web3 space, even with this better onboarding. So first thing we do is we basically have a discussion place, which is sort of a social model. Now, NEAR.org, the way we configure it, all components can be shared using social areas. And components are effectively a way to view data on the blockchain. So if you search for something, or if you view some sort of alien data in an application, it will automatically show you a component which is right for that data, which sort of allows for very, very quick discovery of applications for data that's relevant for you. So you can do sort of a full text search for something you're interested in. For example, an Aurora NFT. You can search for it, and the Aurora NFT box will pop up. You can click it. You're suddenly in the Aurora NFT application. We also roll in a form of notifications. Now, when you move to your own thing, you also need to spin up a notification system too, but we do this for free. Of course, we have the onboarding, which is actually slightly better illustrated now because it's in one place. So, you type in your email, you get an account ID selected for you, you verify your email, and you create a passkey, and you're done. And it's synced between all your different devices. And that is the whole onboarding process. So we onboard people to your app, but we also try and re-engage. So we have the ability to give users NFTs, give them badges. Those badges can, of course, be observed by other applications, which is super helpful for sort of cross-application growth patterns. We have the global search, which allows you to sort of, in this case, search for apps, but in general, you can search for sort of people, which is another widget, or you can search for NFTs or whatever you want. So yeah, acquisition's good. Everything you need to acquire your first 100 users. Next up is retention. You want to keep your 100 users around without having to constantly pour money into acquiring, which is always a bit of a pain. So people aren't going to like your app if they use it once. They're going to start liking it when they've used it 10 times. So we focus a lot on re-engagement. So socials for re-engagement, get pulled back in, get mentioned. Notifications, make anywhere you are on near.org or any of these sort of gateways, you will always get notifications which sort of allow you to keep track of what's going on, because obviously you don't have to go in and check every application that you've used on the boss every time you want to do something. And then finally, you have the sort of last step of getting your users really into your application, which is you've used the engagement, you've used the onboarding, all this kind of stuff, and you finally want to get them off to your own application in your own place. So we have a sort of almost one-click deployment system, which basically sort of, provided you have a Vercel app, will deploy your sort of whole instance of the boss. You can then customize the landing page, so you have it in your own domain, customize the landing page, include what you want to include, don't include what you don't want to include, theme it, do whatever you like, sort of arbitrary code, obviously. And this allows you to sort of make something your own, keep things in line with existing branding. So for example, if you already have a page, you may want to sort of make sure that people aren't being knocked over to somewhere else. And for sort of enterprise customers, they really like having things very much under their control and not have a bunch of other things flying around. And then finally, sort of you've locked people in. That's quite a negative word, but sort of you've got people using your app sort of on your own terms. Let's help you grow. So the first thing is go multi-chain. When users use these applications, they essentially have no concept of what chain they're using. Because the keys are all stored somewhere quite well hidden, in general, users should have the same concept of what chain they're using as you do when you're using AWS or Azure, which is, as a developer, you only expose it if you feel the user needs to know that. And generally, I'd say that's not the case. So if you have an NFT marketplace on Polkadot and you want to start showing one on Ethereum, very, very easy. Or you want to start doing it on Near, you want to do a bit of trading, sort of expand across as many chains as you can. So we have, right now we can currently do it using MetaMask, but in the future, once we have these sort of keys on chain, we'll have the ability to do it using FastAuth, which is a much nicer onboarding experience. You can also scale into new devices. We have a mobile SDK coming out. We have the ability to sort of resize these things, rebuild these things, pull these into different applications and different experiences. So your component may show up in the last place you'd expect it to show up. So if you make a DEX, someone else may integrate it into an app without you even knowing about it, which of course is great for your DEX. And then finally, we have a quite nice ability to sort of fork applications to localize, but also just sort of internal localization, which is very important if you're expanding globally. So yeah, it's mostly reusable. You can pretty much pick up the code you have in React and drop it in. Do it any way you like. do it on any chain you like, and don't burden your users with the cognitive overhead of these kind of things. Localization should work without them thinking. Multi-chain should work without them thinking. These components will work where your users are. So yeah, that's kind of that's broadly our hypothesis with the BOS. We want to make it as easy as possible. We want to basically add as much value when you put your front end where we are. And front ends, they're not the most necessarily glamorous place for a blockchain company, but everything we're doing is on chain. We're using some really top-notch technology. And the great thing about the stuff we built is it looks really easy. It was really hard to build, lots of really nasty stuff, gas models, horrible key sharing algorithms, all this kind of stuff. But your users won't notice any of it. And that's really how we succeed as an industry. When people stop talking about blockchain apps and just start talking about, hey, this is a really cool app I use, and maybe finding out it was decentralized 6 months later. So thanks so much for listening to me. I'm really happy to be talking again at a ParisDOT event again, because I think we should be working together much more than we currently are.
Thank you, David. I got an NFT, that most NFT on here, but I lost my key. Yeah, thank you. So let's now welcome our next speakers playing home, by the way. It's Thomas Letemps from Tezos. Warm welcome to Thomas. Please join me on the stage. Here is your pointer. And the stage is yours. Warm applause, please. Thomas.
Good morning. Okay. So does it work or not? Nope. Okay. Okay, it works. It works too well. Not. Okay. Okay. Sorry about that. So, good morning. My name is Thomas Letemps, and I'm working at a company called Nomadic Labs. And we're working on the Tezos blockchain. So out of curiosity, and I don't see you very well, but out of curiosity, who knows Tezos here already? And so I hope you will be excited to know that this year Tezos is becoming EVM compatible. And today I will use this opportunity, and thank you for inviting us to discuss here, to explain a bit how we are doing that. So let's first discuss about Tezos itself. I won't spend too much time talking about the details, but the key idea that you might need to know to understand the rest of the talk. The first one being that since from day one, we had an on-chain governance system that we used to propose to the community new upgrades for the Tezos blockchain. And it's important to understand that it's fully permissionless and fully open, so anybody can propose new upgrades, and it actually happened. I think that now it happens quite every time that other people from the ecosystem is proposing new upgrades. And we had something like 14, if I remember correctly, we had 14 upgrades on Tezos mainnet since the beginning. And this on-chain governance, it really helps us moving forward over the year, so over the 5 previous years. And in particular, for instance, we've been able to hot-swap the consensus algorithm to go to a deterministic, fully deterministic finality algorithm that is called Tenderbake. We have also been able to rewrite completely our smart contract virtual machine. So Tezos has its own smart contract language, which is called Michelson. So it's not EVM, not Solidity. And more recently, we've been able to bring on mainnet, we've been able to bring optimistic rollups as a first-class citizen, like a first-class citizen optimistic rollup platform on Tezos mainnet. And we are very excited about these smart rollups, as they are called, because we think that they are a game changer for Tezos. They allow, for instance, horizontal scaling. It was probably one of the main initial motivation to get optimistic rollup on Tezos, was to prepare for the future to be able to scale horizontally. And we've been able to demonstrate on a open testnet, 1 million TPS demo with using 1,000 rollups, which is not a small feat as far as we are concerned. But apart from that, apart from the horizontal scaling, what is very interesting for us and for the ecosystem is the new possibilities and the new use cases that smart rollups opens. And I will have the opportunity to discuss more in detail why. But in particular, we will use this avenue of new layer 2s on Tezos to bring EVM compatibility on Tezos, which was something that I've been asked for a long time, and that we are happy to be able to pursue with this layer 2 solution. So out of curiosity, to which extent are you all familiar with optimistic rollups? Okay, so a bit of context, basically. So you have various opportunity to scale horizontally and with layer 2s. Optimistic rollup in particular consists in a particular trade-off where you bring new computational power to your ecosystem, to your layer 1, but you do that with a bit of a trade-off where you ask for infrastructure cost instead. So basically the main idea is that compared to smart contracts, where you execute your decentralized application on the layer 1 itself, on the main network, by all validators, the optimistic rollups allows to move this computation off chain. And so this is why you need some infrastructure in addition to what the layer 1 provide. But when you do that, you get a lot more computational power, and you in the case of the smart rollups that we are proposing on mainnet since March, you are in control of what is happening on the smart rollups. And so smart rollups are really a new way for Tezos to write decentralized application, and it's a way that is a lot flexible to a large extent. So it's not the first time that we are presenting smart rollups, and we have a few properties that we like to put forward when we do that. The first one that set us apart in the realm of optimistic rollup for now is the fact that they are fully permissionless as far as the layer 1 is concerned. So anybody can create smart rollups, anybody can track existing track, and by track I mean computing the state of existing smart rollups, and more specifically anybody can defend the state of the smart rollups. And in particular it means that for interactive fraud proof, they are also permissionless, and if you have an interest in seeing a particular layer 2 optimistic rollup that is living on Tezos be protected because you have asset on it or something like that, you can start your own node and potentially defend it against attackers. The second thing that we like to put forward is that they are enshrined, and by enshrined what we mean is that they have been implemented as first-class citizens of the Tezos protocol, instead of implementing on top of the Tezos protocol as smart contracts. And this gives us a lot of flexibility to, in particular, think very deeply about the interoperability of the smart rollups on the one hand and the existing components, and by that I mostly mean the smart contracts of Tezos. It's also a good opportunity for us to improve a lot, or at least to care a lot about the optimization of the implementation of these smart rollups, and typically to reduce the cost related to the layer 1. And I think like Tezos smart rollups are very, very cheap to operate thanks to that. In particular, in terms of storage cost and things like that, we've been able to have some optimizations that reduce the cost dramatically. And finally, and this is a bit the dual of the first property, they are fully programmable. And what I mean by that is that when you create a smart rollup on Tezos, you provide a WebAssembly program. And this WebAssembly program is the thing that will decide the semantics of the operation and the transactions that are happening on the layer 2. And because you are the one that is creating the smart rollups, you choose this program, and you have a lot of freedom and flexibility about what you want your smart rollup to be. So it can be a very specific thing curated to your chain, to your needs, sorry, and so you will build something like an app chain, or it can be something that is very generalized, like a generalized layer 2, like for instance, Arbitrum can be for the Ethereum ecosystem, and yeah, these use cases can be addressed by the smart rollups. So we are very excited about this solution. The nice thing about the smart rollup being enshrined is that the rest of the ecosystem of Tezos has to care about them and they have to support them. And this is actually pretty nice. So for instance, every time you create a smart rollup, you get for free, to say, a page on, for instance, TZKT, which is a popular indexer on the Tezos ecosystem, that will give you ideas about who is publishing states or what kind of smart contract are interacting with your smart rollup. In addition, you can visualize the fraud proof. So we are calling them refutation game. If you happen to try to read the documentation that we have published, don't be surprised. We are talking about refutation game, and you can see the list of games that have happened for a given smart rollup. So hopefully the list will be empty. Here it's on a test net, so we've actually used this opportunity to test the fraud proof. And so it was not on purpose, but one thing that I like about the screenshot is that it shows how permissionless they are and how decentralized the games are. In particular, you see that you have 2 players, but it's actually a 3rd player that is concluding the game. It's a particular edge case where the players stop to play and a way to unlock the rollup to some extent. And it shows that what we tried to do is if the identity of the person that is injecting the operation is not relevant, then we don't care about it. And we try to leave as many doors open so that as many interested parties, I would say, are interacting with the rollups. So I won't spend too much time explaining technical details, but very quickly, if you're a developer, a DApp developer, and you want to use smart rollups to implement your application, what does it look like? So the key idea is that you have your WASM program, which is run in your layer 2. And this smart rollup program, this WebAssembly program, will have first to fetch data, right, at least from the layer 1. And this is done through what we call the shared inbox. And the shared inbox is really the component that receive all the transactions that go through the layer 1. So one way to inject operation to your smart rollup is to post an operation, a dedicated L1 operation that is transmitted automatically to the layer 2. But if we stop there, then the story becomes a bit strange because I said a bit before that we've been able to demonstrate 1 million transactions per second on open testnet, and 1 million transactions per second is a lot of transactions, and most likely they come with the signatures, or at least in our demos it's the case. We have 1 signature per transaction, and so it takes a lot of space. So how do you deal with that? Well, you deal with that with what we call the reveal channel. And without entering too much into the detail, because if I remember correctly, this is the subject of the next slide, but the reveal channel is a way to import data of arbitrary size inside the rollup. And by doing that, what you get is a way to import megabytes, if you want, of data in your rollup, without having to pay for megabytes of block space in the layer 1, which is both neat and actually needed if you want to scale for use cases like retail or logistic, where you can have a lot of operation, like a huge volume of transactions that will happen from time to time. Then you are able to fetch data inside your rollup. You have something called the durable storage that can be used to retain data. So it's really the storage of your smart contract, but in a way where you don't have to pay for storage, because you have everything that is getting care of off-chain, and so you don't have a way to pay for storage that is used on the validator's nodes, for instance. So basically, the durable storage don't have particular limits in terms of the volume of data that you can store. It has limits about how you store them, but these are technical details related to the refutation game. And as I will have the opportunity to discuss, we try to hide these technical quirks with an upper level of software components. And finally, you have interoperability with the layer 1, not only by sending data, but by sending back data to the layer 1. And by data, I mean really L1 transaction. So you have a way for your smart contract to interact with, for your smart rollup, sorry, to interact with the smart contract. And it does that by sending a message to its outbox. So optimistic rollup brings a bit of friction here, and maybe a bit is an understatement, but you have friction with sending back data to the layer 2, at least in the native way, but it's possible. And so after enough time left for the nodes that are computing your rollup state to verify that this state is correct, you can actually realize this layer 2 to layer 1 operation. And another thing that is important to understand is that every time a Tezos block is created, then you get execution time on your layer 2. You don't have to pay for a layer 1 gas because you are not executing by the layer 1, and you get that for free. And so you can have a lot of freedom again and a lot of versatility on how you deal with this execution time. And one thing, for instance, is that you can decide to send your data by large chunk and spend several Tezos blocks to compute them. And this is also another way to reduce the operational cost with respect to the layer 1 by batching your data effectively. So the reveal channel, one thing that is important to understand is that it doesn't have to be, but it can be a compromise on decentralization, because because the question of data availability become more concrete for you. So if you send your operation to the layer 1, then the layer 1 is the data availability solution that you use. Your data are inside the L1 blocks, and so you don't have to ask yourself how the other users that want to compute the state of your rollup will fetch this data. The layer 1 will fetch them. If you are starting to using the reveal channel, where data are not strictly coming from the layer 1, but from the outside world, then the question of whether or not you will give this data to your user, to the other parties that want to compute, the third parties that want to compute your rollup, becomes more present. So what we try to do, I think it's not a bad thing, in the sense that not all smart rollups need the same level of decentralization. But what we try to do as a Tezos core developers is always to find a way to make you enjoy the most level of decentralization that we can. And in particular, so we've built something that we call the DAC, Data Availability Committees, which is a tool suite, that you can use already, and will act as a third-party provider of data availability, where you would have committee members signing data that you want to inject on your smart rollup, and the semantics of that signature would be that they agree to keep the data available for anyone asking for a certain given amount of time. But again, here we are basically relying on a multisig and the trust that the member of this multisig will do as they say, which is always great enough for a lot of use cases. But if you want more, we are actually building something that we call the data availability layer, which is basically a huge DAC where the member of your DAC are the validators of the Tezos layer 1. And so again, you would have this data availability enforced, or at least ensured by the validators of the layer 1, the same way as the validators of the layer 1 are already ensuring the availability of the L1 history. So if you, behind this QR code, if you're interested, you will find various blog posts explaining both solutions, their respective timeline, and what you can do with them already. And this is only the beginning of the journey. We had a very developer-centric point of view here, and I'm sorry if it was too technical, but once you have your WASM program, once you have the semantics of your DApp, basically, that is expected to run on a smart rollup, you still need to care about how it will be executed, because, as I suggested, before, with a smart contract, it's done by the layer 1 itself, it's done by the validators of the layer 1, and with a smart rollup, it's no longer the case. So you have to answer the question of who and how will your smart rollup will be executed. To do that, so the first thing is that we give you the tool to build it. In particular, we have invested a bit of time and effort in providing an high-level type-safe framework for the app builder in the Rust language. So the Rust is not something that we force on you. If you don't want to use this SDK, you can. But we think that it has a nice property when you try to build something that potentially will handle a lot of data and a lot of money, and you don't want this money to be lost because of bugs. And Rust has a nice property in terms of development that allow to eliminate a large class of usual bugs. We provide also tools to test, inspect, benchmark your smart rollups, which is something that you will definitely want to do. And more importantly, maybe we are providing a general, we call it the rollup node, a general purpose node that will work with your WASM program without having to be modified. So it's really on-the-shelf solutions that you can already use, and that will make it possible to actually compute the state of your rollup, to define the state on the layer 1, etc. And of course, we have I don't know if it's that obvious, we have a track record in providing new features to Tezos. We like to think of Tezos as the blockchain designed to evolve. And we have the same kind of ambition for the layer 2 solutions that we are building. And in particular, it means that the smart rollups as they are now won't be the smart rollup of 2 or 3 or even 3 years in the future, or even a few months in the future. Actually, we already had the opportunity to improve them with the upgrades, the Tezos upgrades that came after the one from March. So in March with Mumbai, we delivered the smart rollups to the Tezos mainnet, and with Nairobi that came, I think, 3 months later, we actually brought new features to smart rollups. Okay, so coming back to the EVM compatibility. So Tezos, as I said, has its own smart contract language that we think has very good properties actually in terms of building smart contracts. That being said, we have had partners that were interested in EVM compatibility for Tezos, and it makes sense in the sense that they potentially had already an existing Solidity code base and they wanted to deploy on Tezos, but they couldn't for free, so to speak, in terms of time of development. So EVM compatibility was something that was requested a lot of time, and we didn't want to add it directly to the layer 1 because it was not the correct layer for us. But with the layer 2 and the freedoms that they brought, it became suddenly a lot more easy for us to actually bring EVM compatibility to the Tezos ecosystem. And this is what we are doing. And when we started, we've quickly discovered actually that an EVM compatible rollup doesn't mean much, or it means too much actually, in the sense that you have a lot of questions that you need to ask yourself before even starting to build your own solution. And you have a lot of cursors to point in various directions depending on your needs. So for instance, do you need low latency in your decentralized application? Most of people do, not all. And low latency using a sequencer bring a lot of challenges in terms of decentralization, because most of the time what they are relying on in particular are centralized sequencer. Another thing is that do you need these arbitrary size blocks or data to inject in your rollup or not? Because those bring other challenges that you need to address if you do. Maybe a bit more surprising, but do you need to pay for gas? In the sense that if you are just interested in a place to deploy your contract, and your decentralized application does not have to interact with the rest of the world, for instance, then maybe you can just have an app chain where you close the doors, but basically people can still look at what is happening, but not inject new smart contracts. And so maybe you don't have to pay for the gas at all. So this is, at the end of the day, what you have to do is ask yourself this bunch of questions and draw this kind of skill maps where you choose on different cursor where you want to be and what are the compromises and what are the things that you are willing to do. And it's a bit too soon for Tezos to answer this question for the rest of the ecosystem. So what we are trying to do and what we are building is a layered answer where first we are trying to keep the WASM program of our EVM rollup as customizable as possible, in the sense that it should be easy, and it is easy, to take the code that we are writing, to tweak the various parameters that I've talked about, and to get your own EVM rollup up and running on Tezos network. That being said, we don't want to stop there, and we are actually in the process of building one instance in particular, an instance where we will put the cursor of decentralization and reducing cost as high as possible, the cursor, not the cost. And so this is our community EVM rollup, And it's a community in the sense that we want it to be a common good for the Tezos ecosystem, a place where you can deploy your Solidity application and enjoy the interaction with the rest of the Tezos ecosystem. And again, if the choices that we are making for the community rollup does not address your particular use cases and your requirements, then you can take the template and redeploy it as expected. So basically, the way we are addressing that is by organizing the code in a way where we deal with block proposal and then validating the block, because these two phases are each one has their specific answer to answer, question to answer. And we also have to care with the rest of the ecosystem, like with the compatibility with the existing Ethereum ecosystem. It would be a shame to start being EVM compatible and not working with all the amazing tools that have been built by the Ethereum ecosystem. And to do that, it's actually a bit of more work for us, in the sense that we don't speak the same language or the same APIs as the rest of as the Ethereum ecosystem. So we are actually building a node that is able to talk, or at least to propose the Ethereum JSON RPC API. And this node is already compatible with a bunch of tools. So for instance, you can already use MetaMask with it. It's already compatible with BlockScout, the indexer, and it's already compatible, or at least partially compatible. I think there are some challenges remaining, but with Remix, the IDE, online IDEs that you can use to test and deploy your smart contracts. And maybe it's compatible with your decentralized application, but maybe it's not the case. So we already have actually a public instance on a testnet that is running the EVM rollup. And you can find some details on following this QR code. And so if you have some time to spare or some interest in coming to the Tezos ecosystem, I really encourage you to have a look at this blog post and to come to our Slack and ask any question, or report your problem and your successes. It will be very welcome. That being said, we are becoming EVM compatible with this community rollup that will be called Etherlink. And if you are interested in that, please feel free to go to Etherlink.comm and register to the mailing list that we have. Globally, we have a lot of ambition for this project. Okay, and to conclude this talk, I don't know if I'm running late or not, but just in case. What's coming next for Tezos? It's far from being over for us in terms of the optimistic rollups and what we want to build with them. The smart rollup as they are now, they are already ready for your industrial use cases, but this doesn't mean that we cannot improve them. And we will do so, in particular by exploring vertical scaling inside the rollup. So I mentioned very briefly at the beginning of the presentation that we are already able to do 1 million transactions per second on testnet using 1,000 rollups. And 1 million transactions, it has a nice ring to it, right? But what we want to do now is try to reduce that, but not with 1,000 rollups, but just with one. And so you would get the vertical scaling of being able to get your own computation time on Tezos almost for free, or at least with very small layer 1 cost. And what we want to do is to allow you to scale vertically, which means, for instance, buying a more powerful machine to handle more data if you so desire. Also, we want to build a universal computing platform. And this is maybe coming back to the fact that for a long time, Tezos has its own smart contract language with a lot of good properties, but with, I would say, some friction for the app developer. And we have a story about bringing EVM compatibility, but we also have a story of other languages that have good properties that are not available on our network. And we want to build a platform where you could implement your smart contract in the language that you chose, and to deal with that for you, to deal with the interoperability with the rest of with the other runtime and the other languages, and so be very welcoming in terms of adoption from this perspective. And so this will be something that we are starting to work on today, and we hope we will accelerate on this subject in the course of the next year. But of course, this year is more about EVM compatibility, at least for the layer 2 part. And again, so it is coming on Tezos mainnet this year with SR-Link, and potentially other and as many EVM rollup as the ecosystem needs to have. And if you have a Solidity decentralized application that you would like to test on a new fun environment with a bit of bleeding edge and fun quirks, for now, don't hesitate to reach out to us so that we can see that happening. We already have some partners that have had some success deploying, for instance, NFT platforms and things like that. Thank you. And yeah.
Thank you, Thomas. So, as a corporate baker, I can only support Tezos. Thank you very much. Yeah, perfect. So, now let's make some noise for our last speaker of the morning session from Polkadot. And so, please, a warm welcome to Sean Lonlege. Please join me on the stage. This is your pointer. Yeah, your turn.
Testing. Let me know if you can hear me. Perfect. Hello, everyone. How's everyone feeling? My name is Sean, and I actually used to be a core dev at ParisDOT. Worked on our Rust Ethereum client back in the day. Rust, or it was ParisDOT Ethereum. Also worked on Substrate, Polkadot. No longer at ParisDOT, but still actively contributing to the ecosystem. I recently made a fellowship member, for those of us who are familiar with the Polkadot Fellowship. And today I just want to talk a little bit about Polkadot interoperability, how that relates to scalability, and sort of the ways in which we can make interoperability today in the ecosystem much better, much more ergonomic, much easier to reason about. So let's just dive into it. So maybe we should take a step back. Why interoperability? What did Gavin would see that made him sort of take the fork in the road and go start off Polkadot? Well, start with some facts. Synchronous application composability is just unsustainable, right? You have a single blockchain network. It has nodes on this network. And they're all just basically re-executing what is the same set of blocks. At some point, you run into this issue where a single application can sort of starve out all of the other applications on this network. Conventionally, we refer to this as thread starvation. But that's bad, right? This is bad for scalability. Also because this drives up the cost for block space, as well as having these multiple applications compete for block space. Some of them might not be able to afford this block space. Like, I just want to transfer some fees. I just want to transfer some funds. NFT mints, they're willing to pay thousands of dollars to mint their NFT. I don't really want to pay $1,000 to transfer $10. That doesn't really make any sense. So Gav says, okay, what if we had multiple blockchains that were specifically tailored to different applications? Now, they don't have to compete for block space. And as a result, you have cheaper transaction fees. You have higher transaction throughput because they're not competing, obviously. And there's more flexibility for app developers because you can now tailor your blockchain at the base layer to be highly performant for your application-specific purposes. And of course, it's kind of a side effect. This introduces a much more sustainable tokenomic model, whereas if you had some dApp, your users essentially have to pay rent to the base layer. And then what's the sustainability of your token model? It doesn't really make sense. But in this new case where the token actually powers the blockchain that your app lives on, then of course you have a much better sustainable model. Okay, maybe it's not all good, this new idea of making everything sort of sharded on its own blockchain. Of course, this introduces the need for asynchronous composition. So applications cannot immediately call another application for some data in the same block. They kind of have to wait for multiple blocks. And you might think that this is bad. I don't think it is, actually. I don't think that it is. And the reason for this is because, actually, let's take a step back into traditional software systems. You have some software, it runs perfectly well on the single-threaded model. You want to scale it up. Of course, you want to add more threads. You want to add more machines. At that point, your process can no longer be synchronous, right? It has to become asynchronous. Actually, you could still hold on to your synchronicity for dear life and try to do mutexes and try to do these locking semantics. Of course, you quickly run into deadlocks and all kinds of other issues that these locking primitives for synchronous communication between threads introduce. And after a while, you become enlightened and realize, okay, maybe I should be doing lock-free primitives like channels, like the actor model, where instead threads just pass messages to each other, telling them what they're doing, and sort of handing off work to another thread, right? So interoperability, if we come back to the Web3 model, is this lock-free message passing for distributed state machines, right? And the ability to do this actually is what unlocks true scalability, right? You can have a single-threaded process and try to maximize how many transactions can fit into that process, into this state machine, but ultimately, you can't beat someone else who can add more state machines to their process, right? The same way you can't beat a multi-threaded process if you're just a single-threaded process. So it's kind of a fun meme. I think that people who are looking for blockchain scalability will eventually realize that they're asking the wrong question, and it's not the answer is not to throw more machines to it. It's not to try to like ZK prove everything, and of course that just leads to centralization. It's really just to add more logical cores to your process. So this is where we start to see, okay, Polkadot actually is leading this interoperability revolution, as it were. Polkadot itself has sort of multiple processes on the relay chain: staking, balance transfers, governance, what have you. And slowly, they are bringing these processes down to what are called system chains. We've already seen a few launched: the Asset Hub. We've seen the collectives. There's also Bridge Hub, which will handle bridges to other ecosystems. But there are more planned. In fact, the idea would be that the relay chain does nothing but just validate parachain blocks. And if you wanted to do, for instance, staking, you wanted to do core management for what is this new core time paradigm that Gav unveiled for his Polkadot version 2.0 model, that will all happen on the parachain level, right? And all of these processes would communicate asynchronously with each other. You can move your assets from the Asset Hub into the staking hub, where you can stake and you can unstake or what have you. But all of this is good and all, but there are still some issues with cross-chain messaging. For instance, how do you guarantee that this remote process or this remote application that you're messaging is executing your messages correctly? The only solution to this would be to obtain some sort of execution proofs, you might say validity proofs. But actually, in Polkadot, we don't need these sort of cryptographic validity proofs, right? The relay chain itself can enforce the execution of messages. And this is what Gav referred to as accords, where essentially parachains will share some code, and the relay chain verifies that this shared code, is being executed correctly. So personally, I don't really like the name relay chain. I think it's an artifact of HRMP, which used the relay chain as a message relay chain. I think Polkadot itself is more of a bridge network in that it facilitates blockchains to communicate with each other, and that's really what it does. And it does so by validating their state transition functions. Okay, I already touched a bit about HRMP, and it's this protocol that uses the relay chain as a transport layer for messages. So parachains, they push messages up to the relay chain, and the relay chain will push messages down to the destination parachain. Fortunately, it's not very scalable. As you can imagine, for instance, if every parachain is pushing messages up to the relay chain, then the relay chain forms what is this bottleneck in parachain messaging. And of course, there's all sorts of issues, in fact. And even with all of the complexity of HRMP, it still lacks the ability to read relay chain state, for instance. You can't even read your sibling parachain state. All you can do is just messaging. And so it calls into question the need for a new, more simple protocol for interoperability. And that's actually what I would like to introduce here today. But of course, another meme just for the vibes, for the parachain developers with us here who are familiar with XCM and sort of the verbosity of XCM. And you just wanting to transfer assets have to now deal with this verbosity. But the thing is, this verbosity has been seen before in, well, in the developer landscape, right? If you remember XML HTTP request, which was the first API that the browser gave to, the general execution environment as to how you could make HTTP requests. A lot of people did not like this. It was a bit too complex. Actually, it was very powerful, right? Because you actually could hook into the literal transport protocol behind it, right? They thought people would want to do all this stuff, but really people didn't care. People just wanted to send messages and receive responses. And so this is, just sort of a meme to show you that we've seen this sort of thing before, and eventually this verbosity made way for more simpler interfaces, like Fetch, Ajax, or Axios. And so like I said, XCM will have to make way for something more simpler that developers can reason about easily. So this is where the sort of interoperable state machine protocol comes in. This is something that we've been looking into since the beginning of the year, sort of asking ourselves, how can we model cross-chain communication in such a way that's easy to reason about, familiar to developers, and doesn't introduce any new cognitive overhead. So we've modeled it after HTTP, actually. So you can imagine you're just doing HTTP requests in a blockchain. Fundamentally, it only allows you to do two things and two things only. Post requests, which is for sending messages, arbitrary messages. We don't actually enforce a messaging format, so you can really put whatever you want into what are these requests. You can put JSON. You could actually also put an XCM message. We don't care. All that matters, though, is that the destination chain or destination module knows how to interpret this message, kind of like how it already exists today in Web 2. You post some data to a remote server, and if the server cannot interpret your message, you get an internal server error. This is how it works. So the same thing should happen in the blockchain space. This research and development, we're lucky to be funded by the Web3 Foundation, and it currently supports parachains today, as well as solo chains. Actually, this solo chain interoperability is powered by our Grandpa Light client. So we have an implementation of the Grandpa consensus protocol. So solo chains can also use ISMP to talk to parachains. But even better, because we have this Grandpa Light client, the Polkadot relay chain and the Kusama relay chain can also interoperate over ISMP. So this is a very, very top-down integration protocol. We already have support for pallets, as modules, as well as the EVM contracts. We're already investigating what it will take to support Ink, and of course the Ethereum blockchain as well in this protocol, as well as its rollups. And like I said, really what you can do with ISMP is you can make these GET requests, and we're already seeing like teams thinking about what this GET request truly means. For instance, Akala will be able to use this to mint what are derivatives of your stake on the relay chain. And even if that moves to a parachain, they can still read a parachain state. For instance, Invarch, who builds DAO tools, are already thinking about how they can use this to implement what is this bribe protocol, where you can essentially read the proposals from the relay chain and then make them available for people to bid on how a pool of funds should vote for these proposals. For instance, we're also seeing multi-asset transaction fee collection for any parachain, using the price data on DEXs in the ecosystem. For instance, Hydra DX is a decentralized DEX, and they can basically be this oracle for price data. As well as Kilts as well, they have this decentralized identity that is on a parachain, but how can you read this information from any chain, really? This is powerful for applications that want to leverage Kilt's decentralized identity system. Of course, we have post requests, which, like I said, allows you to just post arbitrary data to a different blockchain. And the only thing I would say that a developer needs to think about is timeouts. So say you send out some requests and you don't get a response for it, you basically get a timeout. And like, this is not that very complicated, right? It's similar to what you get in HTTP. If you send out a request, you either get a response, you get an error, or you get a request timeout. And so you just have to handle this however you see fit. So this is also another meme about how I see the sort of landscape of interoperability today. We've already seen something that works really well. Somehow, no one else has tried to replicate this in in the blockchain space. Instead, what we've gotten are these very complicated protocols that are trying to do multi-hop routing, trying to do relay incentivization, trying to do four-way handshakes, whereas the answer was in our faces all along. So I'll touch a little bit about, again, what Spree does and why it's needed specifically. So in the parachain model, in the parachain runtime, there's a call that actually allows you to overwrite arbitrary parts of your state, right? Applications have their own state, but there is this frame system that can just write to any part of the state. It needs root, but if a parachain doesn't have pseudo removed, or maybe it's actually not super active and no one's really looking at what governance referenda are being passed, then really a parachain could convince, or parachain A could convince parachain B to mint some infinite amount of funds through just cross-chain messaging, because in the happy path, some funds had to have been burnt before the message gets sent out to, hey, mint these funds. But in this case, parachain A could just write that message directly over, like sort of sidestepping the module that handles this messaging. And that's pretty dangerous, in fact. So this is where we introduce Spree, and so we separate out cross-chain modules themselves into having their own state tree, and the relay chain sort of enforces that these modules are being executed correctly. In fact, if you have a Spree module and you have your conventional runtime modules, they cannot interact. The only thing that can modify your Spree module's state are Spree transactions. So this brings back this trust-free cross-chain messaging that we so desire. And of course, if you wanted to change your Spree module, actually all of the parachains would have to vote on their chains, if they had the governance module, to sort of change this module. And it would have to be a passing vote for all parachains. No single parachain can change the Spree module. So, giving all of these tools, it's clear that Polkadot will be this sort of primordial soup. And this is a reference from abiogenesis, conditions for life 4 billion years ago. Polkadot will have these conditions to spawn the most advanced cross-chain applications, the most scalable cross-chain applications, just because of the tools that parachain developers have at their disposal: ISMP, Spree, XCM. And we're very excited about this. But one thing that I want to sort of bring to top of mind is that these tools don't just enable cross-chain communication, but if you go back to the beginning of my talk, they also enable this multi-core sort of standard for applications, right? So if you think about it, just by having cross-chain communication, you can also use that as a sort of synchronization primitive between multiple instances of your application across different parachain slots or parachain cores. So yeah, what is multi-core parachains actually? I think Gav already described Polkadot as a multi-core computer. And so if you wanted to really make use of all of the resources that Polkadot provides, then it makes sense for you to launch what is a multi-core parachain. So a parachain uses multiple cores. But then how do you synchronize the load, the sort of work that each parachain core is doing? You need cross-chain communication, right? And so this is where cross-chain communication starts to show itself as a scalability primitive. And so, for instance, you could use ISMP to sort of orchestrate multiple worker cores, and you have a master core that just sends work out to these parachain cores. Or you could do long-running computation on one core and read the results of that computation from another more user-facing, lighter-weight core. This is still cross-chain communication, but this is now sort of scalability in play. And like I said, with these primitives, parachains can scale beyond what is possible, really, in any other ecosystem today. And so that's the end of my talk. I just want to leave you with this meme so that we can all start to be these synchronizers of distributed state machines beyond just threads. Thank you.
Thank you, Sean. It was brilliant. Perfect. I hope you guys better understand Polkadot, right? Great. Now it's the time for lunch. So we will be back at 2 p.m. right here with the next speakers with Polygon. So enjoy the meal. Thank you.